So let's start with number 1. For number 1, it says find a coterminal between 0 and 360 for negative 150. And then for number 2, find a coterminal between 0 and 2 pi for 16 pi over 7. So to find a coterminal in degrees, you're going to add or subtract 360. To find a coterminal in radians, you're going to add or subtract 2 pi because 360 and 2 pi are the same thing. So for the negative 150, that's not on my circle because it's too small, so I need it to be larger, so I need to add 360 to that one, and so that would give me my coterminal of 210. 16 pi over 7 is too big. 2 pi is 14 pi over 7, so this is too big to be on the circle, so I would want to subtract 360 or 2 pi from this one. And so I'm going to need a common denominator to be able to subtract. So when I subtract, I'll get 2 pi over 7 for my coterminal. All right, then 3 and 4 ask us to find the complement and the supplement. Remember that a complement, complements are two positive angles that add to be 90 degrees or pi over 2, and supplements are two positive angles that add to be 180 degrees or pi. So if I want to find the complement, I'm going to do 90 minus the angle that they give me. So 90 minus 70 was 20. So similarly on number 4, if I want to find the complement, the same thing that is 90 is pi over 2 in radians. So whereas over here I did 90 minus the angle they gave me, here I want to do pi over 2 minus the angle they gave me. And again, I'm going to need a common denominator for 2 and 5, and then I can subtract. If I'm trying to find the supplement, I would do 180 minus the angle that they gave me. And so over here, 180 is the same thing as pi, so I would do pi minus the angle that they gave me. So 180 minus 70 is going to give me 110 for my supplement. And pi minus pi over 5, again, I need a common denominator. And so when I subtract, I'll get 4 pi over 5. All right, then for 5 and 6, we want to convert back and forth between degrees and radians. So they ask us to convert 12 pi over 7 to degrees. And remember our shortcut for that is that we can just replace pi with what it's equal to in degrees, 180, and then we can just reduce this. So we ended up with 2,160 over 7. And if you'd rather write that as a more normal looking value, if you literally put this in your calculator and divide, you're going to get 308.6. All right, then for number 6, we want to go the opposite way. We want to change from degrees to radians. So to change from degrees to radians, my conversion formula is 1 degree is equal to pi over 180 radians. I don't have 1 degree over here, I have 130 of them. So I'm going to multiply both sides by 130. So now I have the 130 degrees on the left that I needed, and now I just need to simplify my right-hand side. So 130 divided by 180 would reduce to 13 over 8, so we're going to get 13 pi over 8 radians. All right, then for number 7, they ask us to find the arc length when the central angle is 30 degrees and the radius is 3. So we had that formula that arc length is equal to the radius times the central angle, but that central angle has to be in radians. And we can turn this formula around to solve for any of those 3 pieces. So since they told me that I had 30 degrees, we can look on the unit circle and see that's the same thing as pi over 6, or we could use our conversion formula. So they told me the radius was 3, and we just found out theta in radians is pi over 6. So if I multiply those, I'll get 3 pi over 6 or pi over 2. And if you'd rather give the decimal for that, 1.57. All right, then for number 8, it says, let 3, 7 be a point on the terminal side of x. Find the cosine and the cosecant. All right, the most common mistake that I'm going to see here on the test is that you tell me that cosine is 3 and sine is 7, so cosecant is 1/7. The only time that cosine is the same thing as x and sine is the same thing as y is when your radius is 1. If this is x and this is y, there's no way my radius is 1 because the radius or the hypotenuse has to be the longest side, right? So I'm going to use Pythagorean theorem, a squared plus b squared is equal to c squared. So x squared plus y squared is equal to r squared to find my radius. and I'll get the square root of 58. Excuse me. So now that I know x is 3, y is 7, and r is the square root of 58, now I can just use my definitions. Cosine is x over r, so that's going to be 3 over the square root of 58. Of course, we would rationalize that, so we'll multiply top and bottom by the square root of 58, so 3 square roots of 58 over 58. And then cosecant is r over y. So that would be square root of 58 over 7. So square root of 58 over 7. X and y were both positive, so we're in the first quadrant, so we know that all of our answers are going to be positive. All right, then for number 9, it says if tangent is equal to negative 3/4, find cosine x if x is in the fourth quadrant. Okay, well, I know tangent is y over x. So I know that y is 3 and x is 4. I just don't know which one's positive and which one's negative. Well, that's why they told me I'm in the fourth quadrant. In the fourth quadrant, x is positive and y is negative. So if I did Pythagorean theorem, 4 squared plus negative 3 squared is equal to r squared, I would get 5. But hopefully you've seen that combination enough that you recognize your 3, 4, 5 triangle and save yourself having to do that Pythagorean theorem. Remember that if you're doing the 3, 4, 5 triangle, 5 does have to be the radius, the hypotenuse, the longest side. Okay, so now I want to find the cosine, and cosine by definition is x over r. So we're going to take x 4 over r 5, and my answer would be 4/5. And just to double check my sign, in the fourth quadrant, all students take calculus, only cosine is positive, and so sure enough, my answer should be positive. All right, then for number 10, we've got cosine of 40 is equal to the sine of what? Okay, so this is our idea of complementary angles of cofunctions are equal to each other. So let's start with cofunctions, cosine and sine. You either add a co or take away a co to get the cofunction. So cosine and sine, secant and cosecant, tangent and cotangent are cofunctions. All right, then complements are two angles that add to be 90. All right, so if these are cofunctions, then these have to be complementary. It has to be two angles that add to be 90. So all I had to do then was just say, okay, how do I find the complement? 90 minus the angle they gave me would give me 50. All right, then we had the secant of 20 is equal to blank of 70. It's that same idea again. 20 and 70 are complementary, and secant and cosecant are cofunctions. All right, then for number 11, they gave us a figure and they asked us to find this missing side over here. Now, if you'll notice, I know the 45-degree angle, I'm looking for what's opposite, and I know the hypotenuse. So opposite over hypotenuse is sine, so I'm going to say sine of 45 is equal to opposite x over hypotenuse 2. So sine of 45 is equal to opposite x over hypotenuse 2. So to get x by itself, let's multiply both sides by 2. So that would give me 2 sine 45 is equal to x. I can look on my unit circle, and the sine at 45 is the square root of 2 over 2. So when I multiply that by 2, I end up with just the square root of 2. All right, then 12 says a botanist wants to know the height of a tree. So he stands 20 feet away from the base of the tree, and he measures the angle of elevation to the top of the tree as 60 degrees. So what is the height of the tree? All right, so we're looking for this unknown over here. That is opposite of our angle, and we know what's adjacent to our angle. So which trig function uses opposite and adjacent? Tangent. So tangent of 60 would be opposite x over adjacent 20. So multiply both sides of that by 20 to get x by itself. Look on your unit circle and find the tangent of 60. Now, tangent is sine divided by cosine. So we're going to take the sine at 60 and divide it by the cosine at 60. So square root of 3 over 2 divided by 1/2 is the same thing as square root of 3 over 2 times 2 over 1. That would just give us square root of 3. So 20 square roots of 3 would be our answer, or if you'd rather give a decimal version of that, that's fine as well. All right, then 13, they ask us for the sine at pi. So look on your unit circle and go around to 180 or pi. And remember that sine is the y value there, so sine would be 0. All right, and then they asked us for cosine 420. 420 is not on our circle. It's too big, so we would have to find a coterminal by subtracting 360. So if I take 420 and I subtract 360, then I'm going to end up with 60 degrees. So the cosine of 420 would be the same thing as the cosine of 60. So if you look on your unit circle at 60 degrees, cosine, remember, is the x value. So it would be the 1/2. All right, then for 14, we want the tangent of negative 45. Negative 45 not on my circle, so I need to find a reference angle. So if I take negative 45 and I add 360, I'm going to get 315. So tangent negative 45 and tangent 315 are the exact same thing. So look on your circle and see what your tangent value is at 315. Now again, tangent is sine divided by cosine. So we're going to have negative square root of 2 over 2 divided by positive square root of 2 over 2. So that's going to give us a negative 1. All right, then cosecant 13 pi over 6. That one's too big, so I need to find its coterminal. So I'm going to subtract 2 pi, and I need a common denominator if I do that. So 13 pi over 6 minus 12 pi over 6 would give me 1 pi over 6. So cosecant 13 pi over 6 is the same thing as cosecant 1 pi over 6. Remember, cosecant is just sine turned upside down. So if we look at the sine of pi over 6 on our unit circle, that's 1/2. And so if I turn 1/2 upside down, then I'll get 2. All right, then for number 15, they ask us to find the secant of 150. Okay, well, secant is 1 over cosine, so let's go to the unit circle and let's find the cosine at 150. So go to 150 and look at your x value, and you should see negative square root of 3 over 2. So secant is the reciprocal of that, means I just need to flip that. So that would be negative 2 over the square root of 3. And of course, we're not going to leave a radical in the denominator, so multiply top and bottom by the square root of 3. And we'll get our answer, negative 2 square root of 3 over 3. All right, then cotangent negative 5 pi over 4. Negative 5 pi over 4 not on my circle, so let's find a coterminal. So we'll just add 2 pi to get our coterminal of 3 pi over 4. So the cotangent of negative pi over 4 is the same as the cotangent of 3 pi over 4. Cotangent comes from flipping tangent, so let's go find the tangent of 3 pi over 4. So tangent of 3 pi over 4, if you look on your circle, tangent is sine divided by cosine, so that's going to be a positive square root of 2 over 2 divided by a negative square root of 2 over 2, so that's going to be a negative 1. So if I take negative 1 and I turn it upside down, that would still be negative 1. So that would be my answer for the cotangent. All right, then for number 16, what is the reference angle for a couple of these guys? So remember that if you have a pi over 4, a pi over 3, or a pi over 6 in your angle measure, that is your reference angle. So this one has a pi over 6 in it, so that is my reference angle. All right, then 240. 240 is in the third quadrant, and in the third quadrant we take our angle and we subtract 180 or pi from it. So for us, if we take 240 and we subtract 180, then we'll get our reference angle of 60. So exact same thing right here with 3.8. 3.8 is in the third quadrant. So 3.8 minus pi, because that's the same thing as 180, right? So 3.8 minus pi would give us 0.66. Now, if you're not sure how to know that 3.8 is in the third quadrant, remember that we gave decimal values for each of our quadrants. So we said that 90 was the same thing as pi over 2, which was 1.57. 180 was the same thing as pi, or 3.14. 270 was the same thing as 3 pi over 2, or 4.71. So 3.8 has got to be between 3.14 and 4.71. That's how we know it's in the third quadrant. All right, then 17, we want to know what is the quadrant where cosine is negative and cosecant is positive? All right, well, cosine is negative in the second and the third quadrant. Remember, it's the same thing as x. And then cosecant is the same thing as sine, or the same thing as y. So sine, or y, is positive in the first and the second. So the only place that both of those things could be true then would be the second quadrant. Similarly with number 18, they want to know where is cotangent negative and secant positive, right? So cotangent and tangent are the same, so they're negative in the second and the fourth, and secant is the same as cosine, or x, so it's positive in the first and the fourth. So the only way both of those would be true is if I was in the fourth quadrant. And then last, we want to know the tangent at negative pi over 2 and the cosecant at pi over 2. All right, so first off, negative pi over 2, not on my circle. I need to find a coterminal. So I'm going to add 2 pi to that. And when I do, I get 3 pi over 2. So we're looking for the tangent at 3 pi over 2. So if you go to 3 pi over 2 on your unit circle, tangent is sine divided by cosine. So you'll see the sine is negative 1 and the cosine is 0. Division by 0 is undefined, so we literally just say the tangent is undefined. All right, then cosecant at pi over 2. Remember, that is the reciprocal of sine, so all we need to do is find the sine value and turn it upside down. So if you look at pi over 2, or 90 degrees, you can see your y value there is positive 1. So if sine of pi over 2 is 1, then turn that upside down and cosecant would also be 1.